Hey, today's date is the 23rd of April 2026. The time now is 3:24 p.m. The video is on um, how to phrase how to phrase a statement as a question. How to phrase a statement as a question. How to phrase a statement as a question. Why does this matter? A probe system can ask a question. So a system can ask a question. A system can probe a result, probe a system. Informally, we can express this as a statement, expression, and intent. A statement is true or false, binary probe. Expression is after some kind of structure. So we take some kind of object, so some kind of structure. A structure is like a C structure of the resultant probe, like the object, in terms, or a function. So this can be modeled as a factory function. And the probe kind of goal I'm trying to have is to define a probe in Python, a class that has a statement, true or false, a trinary statement, true, false, and maybe, let me try this, a class of statements. A statement is a state of an enumeration of yes, no. This is a binary statement. And you're gonna have a binary statement of yes and no uh, as a value result. We can add maybe yes, maybe no, maybe yes, maybe no, as if you want consent and consensus. But the goal is to have this formalized first. So let's stick with binary statements. Uh, a ternary statement will have yes, no, and maybe. It's gonna have a yes, no, and maybe. A ternary statement. I'm trying to express that a system to phrase a question, as so I'm gonna have the MOOC OS and the Singing protocol. Did you eat today? This is a yes, no, and maybe question. Maybe, maybe not. Maybe yes, maybe no. Um, if I ate today, I respond with yes. If I didn't, no. Maybe the maybe says, do you need more time? Or do you need more space? Like space as in computational bytes. So the token model is token type, token value, and token memory that allocates time. Token memory is really the allocation of token to the byte. But a probe is a question. So I'm trying to get a who to ask me questions. Ask me questions. So it's gonna ask me, do I need food or more time? Informing them, but the formal structure of this kind of systems. For example, for any kind of binary statement, let's take var. Let's say Python code. A Python statement like a binary tree logic. Can have a logic. So let's gonna have a Python expression. N equals everything equals 42. Where's my phone? I just really can't find my phone. This is annoying. Everything equals 42. Basically, let's just answer equals 42. Now, basically, a statement here, this is a statement, and the statement holds in memory 42. Uh, so basically, you get the left side of the token is answer. So answer is the left side. The left upper the left operand is answer. This left operand is an identifier. The equals is an operator, and the answer is a literal number that's bound by token type, token memory, and token value. So this is the anti system, but I'm trying to express that answer is 42. This is just a simple statement. Now, if you have an expression, if you use an expression, expression values to true or false. So this is bound by expression. So you're gonna have expression, expression. So if answer less than 100, you know, um, if answer less than 100, basically, let's just play 122. So the whole things is to evaluate less than equal to 100. The beautiful thing is to evaluate the system I'm building. So basically, you have a probe. So the goal is ask the question: did you eat today? And system will say I ate today. Now that probe is a statement, but I'm trying to take that I ate today to a question. So that'll be basically maybe I ate today. Because it's maybe I ate today, it's a special kind of system. Basically, when an observer takes when someone that's reading these inputs, maybe I ate them, they have to answer yes or no, and that statement will evaluate to three things. So a statement can evaluate yes or no, a true statement is yes, no, and maybe a trinity statement. A trinary logic, a trinary expression will give object return or some kind of data, some kind of what's kind of the probe, and that's like the data logic. So the kind of data statement will be yes, no, maybe. But if like if a GE today it should be yes, no, yes or no, because this will not be an object model. This will be what to be objected. But this will be what the objects will have. So those will have some kind of model, yes or no. But it's a binary logic. So doesn't matter what the system makes mention, or it's a lower interpretation. You're gonna have the output of that abstraction to tree. I'm talking pseudoscience. If you're not talking pseudoscience here, but I'm trying to get a system to ask a question. Formally, basically, if you have some kind of encoding in thinking encoding SIGI file, you need to ask the question, it's a probe, and the probe is symbolic. So symbolic is a symbolic interpreter. So basically, you're gonna have any kind of interpretation language, determining kind of the meaning for that language. So you're gonna have a Python, a Python target language like Lua. So if you use it, I'm gonna write in C. I'm gonna use to interpret um, in Sigil C. I'm gonna write this guy in Sigil C, but I'm trying to output through interpretation of a system. So you're gonna have a probe. Let's go to probe. This you're gonna have the system ask a question based on who, what, when, where, why, there and then, there and then, there and then, when, where. But it's not that it's abstract. It's not a student. It's not a student style. But it's going to take a statement to make it to a question. That's not to resolve somehow. And that's through interpretation. So you get to try the intuition. You can have like a graph system. Basically, you can have the graph. Whatever is being exposed to resolve a meaning for that system. So, I've done really badly here, but I've started. So that's what I'm saying. So, you have to ask the question. And that's the instrument. Listen, you're going to have minus one, minus one, and minus one. It's going to have a whole set of minus one to the power of three. So, you're going to have three whole sets, do you need more time? Do you need more space? So you can understand intent. So basically, that's my article on Dev 2. So, the groups that have the system asks a question, an interpreter program respond. And this would be a Muco DLL, DLL, Muco Dynamic Library, that's stateless. It's a stateless system. It continues its operation. It's not it doesn't inspire. It doesn't inspire because he has to operate as some kind of symbolic interpreter. So, I dropped my pen. So the goal is to have system respond logically. So you're gonna output some kind of a syntax basically. I can't wait to go back to Nigeria, guys. I'm not British. Thank you for watching this video.